Hello, and welcome to the Bedtime Lab, a cozy corner of the universe where we gently unravel the mysteries of science to lull you into a peaceful slumber. Tonight, we're embarking on a serene journey through the cosmos, exploring the captivating concept of Dyson spheres and other awe-inspiring megastructures. Imagine settling into a plush armchair in a softly lit library where each page turned reveals a new wonder. As we begin, I invite you to share where you're tuning in from. It's always such a delight to know how far our whispers travel, connecting us across the vastness of space and time. Let's start with a little thought experiment. Picture a civilization so advanced that it constructs a colossal shell around its star, capturing every ray of light to fuel its needs. This is the essence of a Dyson sphere, a concept that, believe it or not, was first introduced by a visionary physicist named Freeman Dyson in 1960. It's a little mind-boggling, isn't it? Imagining a structure potentially large enough to envelop an entire star. Speaking of stars, did you know that a Dyson sphere, in its grandest form, would have a diameter of about 1 astronomical unit? That's the average distance from the Earth to the Sun, approximately 150 million kilometers. Just picture that for a moment, a structure so vast it could contain our entire solar system. Here's a fascinating tidbit. The idea of harnessing the power of a star is not just science fiction. In fact, it highlights humanity's eternal quest for energy. You see, our current technology allows us to capture only a minuscule fraction of the sun's energy. But with a Dyson sphere, a civilization could harvest nearly 100% of a star's output. Isn't it intriguing how our dreams of the future often push the boundaries of our current understanding? And here's something else to ponder. Not all Dyson spheres are envisioned as solid shells. Some theories suggest a swarm of solar-collecting satellites could achieve the same effect, each one dancing in a complex orbital ballet. This swarm could be composed of millions of smaller, interconnected structures, each meticulously balancing itself to avoid collision. Can you imagine such cosmic choreography? Speaking of cosmic scales, let's take a moment to marvel at the concept of megastructures in general. These are not just limited to Dyson spheres. There are myriad fantastic designs, each more imaginative than the last. Have you ever heard of a stellar engine? It's a theoretical megastructure that could move an entire solar system. This ambitious dream involves harnessing the energy of a star to propel the system through the galaxy. A cosmic voyage beyond our wildest dreams. Let me share another fascinating idea: the Alderson disk. This hypothetical structure is an enormous flat disk with a star at its center, featuring a hole cut out to allow planets to orbit. It's mind-bending to imagine a structure with a diameter of several astronomical units, providing an almost limitless surface area for habitation. Now, imagine another creation, the Niven Ring, or Ring World, named after science fiction author Larry Niven. This is a ring-shaped megastructure that encircles a star, with its inner surface providing a habitable area. The sheer magnitude of the Ring World concept is staggering, offering a living space millions of times greater than Earth's surface. Here's something curious. While these ideas stretch the limits of our imagination, they also inspire real scientific inquiry. Scientists and engineers explore these concepts as a way to think beyond our current limitations. They challenge us to dream bigger and reach further, pushing us toward new technological horizons. Speaking of dreams, have you ever wondered about the implications of such colossal projects? Constructing a Dyson sphere, for instance, would require materials on a scale we can barely comprehend. Some theories suggest dismantling entire planets for resources, a concept as daunting as it is fascinating. And yet, despite these challenges, the allure of megastructures endures. They represent the ultimate triumph over cosmic obstacles, a testament to the ingenuity and determination of advanced civilizations. It's a comforting thought, envisioning a future where we've learned to harness the very stars themselves. As we drift further into this fascinating topic, let's reflect on how these ideas, while seemingly fantastical, offer a glimpse into the boundless possibilities of our universe. They remind us that while our feet may be firmly planted on Earth, our dreams can soar to the furthest reaches of the cosmos. I hope you find comfort in these musings as you settle into your own dreamscape. There's something so soothing about letting your imagination wander among the stars, isn't there? And as we continue to explore, remember that these stories are as much about the journey as they are about the destination. So, wherever you are in the world, thank you for joining me on this tranquil odyssey through the universe. Together, we'll discover more wonders as we drift gently into a restful night. Sweet dreams, dear friend, and may the stars guide your way. Let's continue our celestial journey, exploring the realm of Dyson spheres and megastructures with fresh eyes. Just imagine the sheer audacity and wonder of constructing such colossal structures. Here's a surprising insight. Building a Dyson sphere would require an unimaginable amount of material, possibly leading us to mine asteroids or even entire planets. Imagine a civilization advanced enough to scoop up a planet piece by piece to create something so grand. Speaking of resources, did you know that the energy captured by a Dyson sphere could potentially support a population of billions, even trillions of beings? This energy could power technologies we can only dream of today, like faster-than-light travel or universally accessible clean energy. It's a vision of abundance that transforms our understanding of what's possible. Let me share another intriguing possibility. Not all Dyson spheres would be inhabited. Some designs suggest these structures could serve as massive data storage systems, with a potential to store the entirety of a civilization's knowledge. It's like an interstellar library preserving the legacy of a species for millennia. And here's a thought that might surprise you. While Dyson spheres capture the imagination, they're just the beginning when it comes to megastructures. Consider the concept of a Shkadov thruster, a megastructure that uses the light pressure of a star to generate propulsion. This could allow a civilization to move entire star systems across the galaxy, a breathtakingly ambitious idea that stretches the limits of current astrophysical understanding. Speaking of moving stars, imagine a matryoshka brain, a series of nested Dyson spheres, each layer capturing the waste heat from the one inside. This setup could create a staggeringly powerful computational device, perhaps even capable of hosting entire virtual realities. It's fascinating to think that such a structure could serve as the ultimate supercomputer, processing information at unimaginable scales. Now consider this. While a full Dyson sphere might be out of reach for now, a Dyson swarm could be more realistic, consisting of countless small satellites equipped with solar panels. This approach allows for gradual construction and scalability. It's a step-by-step method to cosmic energy mastery, a path that shows us how patience and persistence could unlock the stars. Here's another curious twist. Some propose that Dyson spheres might already exist in the universe, as their distinct signature could be detected through infrared signals. Imagine astronomers scanning the skies, searching for these cosmic beacons, each one a potential message from advanced civilizations far beyond our own. And speaking of discoveries, The concept of a Dyson sphere even influences our search for extraterrestrial life. By looking for energy signatures that don't match any known natural phenomenon, scientists open new doors in the quest to find out if we are alone in the cosmos. Who knows what wonders such a search might reveal? Moving from the grand to the even grander, let's turn our gaze to the concept of a halo drive. This theoretical construct uses the gravitational slingshot effect around black holes to propel spacecraft at incredible speeds. It's a reminder of how cosmic forces, often seen as daunting, could be harnessed for interstellar travel. And here's a wonderfully strange notion. Some scientists speculate that an advanced civilization might camouflage a Dyson sphere to avoid detection, cloaking it in a way that mimics natural phenomena. It's a tantalizing possibility that adds a layer of mystery to our understanding of the universe, suggesting that some of its secrets might be hidden in plain sight. In the realm of extraordinary ideas, imagine a world ship, a self-sufficient vessel large enough to house an entire civilization during long voyages between stars. These ships, often depicted in science fiction, serve as a testament to humanity's enduring desire to explore and settle the universe. As we ponder these possibilities, it's interesting to consider the ultimate purpose behind such grand designs. Are they merely a means to an end, or do they represent something deeper, a profound connection to the cosmos, and a desire to understand our place within it? It's a question that invites reflection, encouraging us to look inward as much as outward. And so, as we drift through these thoughts, let's carry the wonder of these ideas with us. They remind us that despite the challenges we face, the universe is vast and full of potential. It's a comforting thought, isn't it? That no matter where we are part of something much larger, something full of infinite possibilities. May these musings gently guide you to a place of rest, where dreams intertwine with the stars. Remember, as you close your eyes tonight, that every whisper of imagination brings us one step closer to the stars. Rest well, dear friend, and let the cosmos cradle you in its timeless embrace. Let me share another captivating detail with you. Dyson spheres, in theory, could drastically alter the appearance of their host star. Imagine a star that suddenly dims or even vanishes from the visible spectrum, replaced by a different kind of glow in infrared. This is because the vast structure would absorb most of the star's light, converting it to energy for its inhabitants, while re-emitting it as heat. This transformation holds profound implications for astronomers, as it challenges the way we identify and understand celestial bodies from afar. An interesting thought to consider is how a Dyson sphere orbits its star. While the traditional concept is a solid shell, more plausible models suggest a cloud of solar panels or Dyson swarms that orbit at various distances. These swarms can be adjusted over time, allowing the structures to adaptively optimize energy collection. Isn't it fascinating how such flexibility might aid in managing and distributing power across vast distances? Here's something that might spark your curiosity. The construction of these megastructures would likely require the use of self-replicating machines. Picture tiny autonomous robots that can mine materials and build components without human intervention. These machines could exponentially accelerate the construction process, paving the way for larger and more complex endeavors than we can currently imagine. It's a testament to how advanced technology might one day become. Reflecting on the impact of these ideas, consider how building a Dyson sphere could influence a civilization's culture and priorities. Such a monumental project would require immense collaboration, likely leading to significant advancements in engineering, cooperation, and perhaps even societal values. The creation of a Dyson sphere could unify a civilization around a shared vision of progress and sustainability. Have you ever wondered how such a structure could withstand the harsh conditions of space? The answer might lie in materials science. Innovations in ultra-lightweight yet incredibly strong materials, capable of enduring extreme temperatures and radiation, would be essential. These materials could transform not only our approach to building in space, but also have applications here on Earth in architecture and infrastructure. Let's delve into another surprising aspect. Dyson spheres present intriguing possibilities for communication technology. Imagine transmitting signals across interstellar distances using light or even gravitational waves. Such advanced communication networks could enable civilizations to stay connected, sharing knowledge and culture across the cosmos. It's a beautiful vision of a universe united by the flow of information. Thinking about the broader implications, it's possible that the existence of megastructures could alter our understanding of physics itself. The immense scale and complexity of these constructs might reveal new phenomena, challenging our current theories and inspiring fresh insights into the fundamental laws of the universe. It's a humbling reminder of how much there is still to learn. And on the topic of learning, consider the potential educational impact of these projects. The pursuit of building a Dyson sphere could inspire generations of scientists, engineers, and dreamers, igniting a passion for discovery and innovation. This grand endeavor could nurture a culture of curiosity and creativity, essential traits for any civilization looking to explore the stars. Speaking of exploration, a fascinating notion is how Dyson spheres could serve as launch pads for interstellar travel. By harnessing the vast energy they collect, these structures could power spacecraft capable of reaching distant stars, opening new frontiers for exploration and settlement. It's a thrilling possibility that extends the reach of civilization far beyond our solar system. Another intriguing idea is the concept of virtual worlds hosted within these megastructures. With their immense computational capabilities, Dyson spheres could host simulated environments where inhabitants experience realities limited only by their imaginations. These virtual worlds could offer new forms of living, learning, and interacting, enriching the lives of those within. Isn't it remarkable to think about how the pursuit of such grand endeavors might change our perspective on life itself? The challenges and achievements of constructing megastructures like Dyson spheres might lead to profound philosophical reflections on our role in the universe. It's a journey that invites us to question what it means to be human and to explore the potential of our collective creativity. And here's a delightful twist. Some suggest that studying the feasibility of Dyson spheres could even help us address pressing issues here on Earth. By developing technologies for efficient energy collection and sustainable living, we might find solutions to problems like climate change and resource scarcity. It's a hopeful vision that aligns the dream of reaching the stars with the necessity of caring for our home planet. As we ponder these extraordinary ideas, they remind us of the infinite potential within the universe and within ourselves. The concept of Dyson spheres and megastructures ignites our imagination, encouraging us to dream big and think beyond the limits of our current understanding. Let these thoughts gently guide you as you drift into rest, wrapped in the comforting knowledge that we are all part of a vast, wondrous cosmos. Each star holds a story, and perhaps one day the stars will include the tales of our own cosmic adventures. Rest easy, dear friend, and let the universe cradle you in its timeless embrace. One fascinating aspect to contemplate is the potential scale and scope of a Dyson sphere. Imagine a structure so vast that it could encompass an entire solar system, To put this into perspective, a Dyson sphere encircling our Sun would have a radius of about 150 million kilometers, the same distance as Earth from the Sun. Such a grand scale is truly beyond our current capabilities, yet tantalizing to envision. It's a reminder of how far human ingenuity might one day take us. Did you know that the idea of Dyson spheres originated not with engineers or scientists, but with science fiction writers? The concept of harnessing the energy of a star first appeared in fiction, inspiring generations of thinkers to consider the practicalities of such a feat. This interplay between imagination and reality often sparks innovation, showing how creativity can lead to groundbreaking ideas. Let me share another intriguing thought. The presence of a Dyson sphere could be detectable from Earth. If a star's light dims in a way that can't be explained by natural phenomena, it might indicate the construction of a megastructure. This method of detection, known as the transit method, is similar to how we discover exoplanets. It's fascinating to think that our search for alien life might one day uncover evidence of extraterrestrial engineering. Speaking of detection, another possibility is that Dyson spheres could emit specific types of radiation signatures. A fully operational Dyson sphere would absorb most of the light from its star, re-emitting it as infrared radiation. This unique signature could serve as a clue for astronomers scanning the skies, offering a tantalizing hint of advanced civilizations. Here's something else to ponder: the concept of a Dyson bubble instead of a solid sphere. This more flexible approach involves creating a network of satellites or panels that orbit the star independently, forming a loose shell. Such a structure would be easier to construct and maintain, allowing for repairs or upgrades without impacting the entire system. It's a clever adaptation that emphasizes practicality over sheer ambition. Have you ever considered the environmental impact of constructing such a massive project? While it might seem counterintuitive, a Dyson sphere could potentially help mitigate climate change. By providing an immense source of clean energy, it could reduce our reliance on fossil fuels and diminish our carbon footprint. It's a solution that, while currently theoretical, highlights the potential for technology to address global challenges. On the topic of energy, Dyson spheres might offer a staggering increase in available power. The energy output from our Sun is estimated to be about 400 trillion watts. Capturing even a fraction of this energy could revolutionize every aspect of life, powering technologies and endeavors we can barely imagine today. It's a testament to the transformative power of energy resources. Here's another surprising fact. The concept of megastructures isn't limited to Dyson spheres. Other futuristic ideas include ring worlds and orbital habitats. A ring world, for instance, is a massive ring encircling a star, with habitable space on its inner surface. These intriguing concepts offer different visions of how civilizations might expand and thrive beyond their home planets. Imagine the sociological changes that might accompany such ambitious projects. The construction of a Dyson sphere would likely necessitate unprecedented levels of collaboration and resource sharing. This could foster a sense of unity and shared purpose across a civilization, potentially transforming social dynamics and cultural values. It's a fascinating reflection on how technological pursuits can resonate deeply within society. Have you thought about the engineering challenges involved in maintaining a Dyson sphere? One critical issue is keeping the structure stable and aligned with the star. Even minor deviations could lead to catastrophic consequences. Advanced technologies and precise calculations would be essential to ensure the sphere's integrity, showcasing the immense complexity of such an endeavor. Another intriguing aspect is how a Dyson sphere could function as a giant observatory. By placing sensors and telescopes throughout the structure, it could serve as a platform for studying the cosmos in unparalleled detail. This would allow scientists to explore the universe from a unique vantage point, opening up new avenues of astronomical research. Here's a delightful twist to consider. Dyson spheres might one day become homes to artificial intelligence. These powerful structures could provide the computational resources needed for advanced AI systems, supporting a new form of digital life. It's a thought-provoking scenario that blurs the lines between organic and synthetic existence. And finally, let's ponder the philosophical implications of these megastructures. The pursuit of such grand designs invites us to question our place in the universe and the legacy we wish to leave behind. As we dream of reaching the stars, we are reminded of our shared humanity and the limitless potential of our collective imagination. Each step toward these ambitious goals reflects our enduring curiosity and desire to understand the cosmos. As you relax and let these thoughts drift through your mind, picture the stars as beacons guiding us toward future possibilities. The universe is vast and full of wonder, much like our capacity for exploration and discovery. Let these musings gently accompany you as you rest, knowing that the journey of learning and dreaming never truly ends. Did you realize that constructing a Dyson sphere would require an amount of materials so vast it might surpass the mass of all the planets in our solar system? Imagine sourcing the necessary resources, perhaps from asteroid mining or dismantling uninhabitable planets. It's a colossal task that highlights the sheer scale of engineering required for such a venture. Speaking of resources, another captivating idea is the use of self-replicating robots to build these megastructures. These machines could continuously produce copies of themselves, exponentially increasing the workforce available for construction. This concept, known as von Neumann probes, illustrates how automation could play a crucial role in realizing such grand projects. Let me share something intriguing: the idea of a Dyson swarm. Instead of a single solid structure, this concept involves a collection of energy-collecting devices orbiting a star. This modular approach could be more feasible than constructing a solid sphere, allowing for gradual expansion and adaptation as technology improves. It's a flexible strategy that could make the dream of harnessing a star's energy more attainable. Did you know that the theoretical material required for building a Dyson sphere would need to be incredibly strong and lightweight? Current materials, like carbon nanotubes, offer a glimpse of what's possible, but future advancements might bring new discoveries. The search for suitable materials is a testament to the blend of innovation and necessity driving such endeavors. Here's a thought-provoking fact: megastructures like Dyson spheres could offer a solution to planetary overcrowding. By providing vast new spaces for habitation and agriculture, these structures could alleviate the pressures of population growth. It's a vision of the future that combines sustainability with the limitless expanse of space. And imagine this: the interior surface of a Dyson sphere could potentially create a controlled environment, free from natural disasters and extreme weather. By regulating climate and weather patterns, inhabitants could enjoy stable and predictable conditions, fostering a new way of life that harmonizes with advanced technology. On the topic of habitation, have you ever considered the potential for biodiversity within a Dyson sphere? By recreating diverse ecosystems, these structures could become sanctuaries for endangered species, preserving Earth's biological heritage. It's a compelling vision of conservation on a cosmic scale, ensuring that life continues to thrive beyond our planet. Here's an exciting idea: the concept of a stellar engine. Some theorists speculate that a Dyson sphere could be used to move an entire solar system. By strategically redirecting solar energy, it might be possible to nudge a star and its planets through the galaxy. This notion of cosmic navigation expands the possibilities of what advanced civilizations might achieve. Speaking of movement, envision the potential for a Dyson sphere to serve as a launch platform for interstellar travel. The abundant energy it provides could propel spacecraft to distant stars, opening up new frontiers for exploration and colonization. It's a reminder of the interconnectedness of technological progress and the human spirit of adventure. Let me tell you about an unexpected benefit. A Dyson sphere could act as an enormous shield against cosmic threats. By absorbing hazardous solar eruptions or deflecting asteroids, it could protect life within its confines. This defensive capability underscores the protective potential of these structures, envisioning a future where humanity is safeguarded from spaceborne dangers. And here's something else worth pondering: the aesthetic possibilities of a Dyson sphere. Imagine a structure that not only serves functional purposes, but also reflects the artistic and cultural values of its creators. The design of such a megastructure could become a monumental expression of creativity, a testament to the civilization that built it. Speaking of creativity, consider the potential for cultural exchange facilitated by megastructures. As societies expand into space, these structures could become melting pots of ideas and traditions, fostering a new era of interconnectedness. The cultural evolution that might arise from such interactions is a fascinating aspect of humanity's journey into the cosmos. Have you thought about the potential for a Dyson sphere to influence time perception? The vastness of such a structure could alter the way inhabitants experience time, perhaps leading to new societal rhythms and traditions. It's a curious possibility that speaks to the profound impact of environment on human culture and psychology. Let me leave you with a final intriguing thought: the philosophical implications of creating a Dyson sphere. As humanity takes on the role of cosmic architect, it invites reflection on our responsibilities as stewards of the universe. The pursuit of such grand designs asks us to consider not just the technical challenges, but also the ethical and moral dimensions of our actions. As these ideas swirl gently in your mind, remember that the universe is full of wonders waiting to be discovered. Each fact we explore is a step on a journey through the cosmos, a reminder of our capacity to dream and create. Let your thoughts linger on the possibilities as the stars beckon us toward new horizons and the promise of what might one day be achieved. Have you ever wondered about the sheer number of energy-collecting devices that might make up a Dyson swarm? Imagine millions of small satellites working in perfect harmony to capture solar energy. Each piece would independently orbit the star, collecting and transmitting energy back to where it's needed. This decentralized approach reduces the risk of catastrophic failure, since losing one of these devices doesn't affect the function of the whole system. This resilience is crucial for the long-term sustainability of such ambitious projects. Now, let's think about the potential for communication within a Dyson sphere. With the vast distances involved, traditional radio signals might not be efficient. Instead, advanced methods like quantum communication could be employed, allowing instantaneous data transfer across the structure. This cutting-edge technology, which uses the principles of quantum entanglement, could revolutionize how information is shared in such large-scale habitats. Speaking of communication, did you know that a Dyson sphere might also serve as an enormous astronomical observatory? By blocking out the light from its own star, the interior of the sphere could provide an unparalleled view of the universe. This would enable inhabitants to study the cosmos in incredible detail, perhaps revealing secrets of the universe that are currently beyond our reach. Here's a fascinating possibility. What if a Dyson sphere could also function as an energy storage system? In this scenario, surplus energy collected during peak solar output could be stored for later use. This capability would be extremely valuable, ensuring a stable energy supply even during periods when solar collection is less efficient. It's a reminder of how these structures could address not just energy production, but also management and conservation. Consider this. The construction of a Dyson sphere might require cooperation on a galactic scale. Civilizations across different star systems could pool their resources and knowledge to achieve a common goal. Such a collaboration would be unprecedented, fostering unity and mutual understanding among varied cultures. This aspect of interstellar diplomacy could lead to a new era of peace and shared progress, transcending individual planetary concerns. And here's something curious. A Dyson sphere could potentially alter the gravitational dynamics of its solar system. By redistributing mass and energy, it might influence the orbits of surrounding planets and moons. This change could have profound implications for the stability of the solar system and require careful planning to avoid unintended consequences. It's a delicate balance of celestial mechanics that highlights the intricate relationship between architecture and astrophysics. Let me share something surprising. The concept of a Dyson sphere is not limited to stars similar to our Sun. Theoretically, such structures could be built around other types of stars, including red dwarfs and even more exotic objects like neutron stars. Each type of star presents unique challenges and opportunities, offering a diverse range of environments for potential megastructures. This diversity expands our understanding of where life might flourish beyond Earth. Have you ever imagined the potential for a Dyson sphere to be a hub for technological experimentation? With abundant energy and resources, it could become a center for innovation where cutting-edge technologies are developed and tested. This aspect of Dyson spheres is particularly exciting, as it suggests a future where scientific progress is accelerated by the very infrastructure we create. On a similar note, consider the implications for art and culture within a Dyson sphere. With vast amounts of space and resources, creativity could flourish in unprecedented ways. Artists and creators might explore new mediums and techniques, inspired by the unique environment and its possibilities. This cultural renaissance could lead to a rich tapestry of expression that celebrates the diversity and ingenuity of its inhabitants. Here's an intriguing idea. A Dyson sphere might enable the study of artificial gravity. By rotating sections of the structure, inhabitants could experience varying degrees of gravity, providing valuable insights into its effects on human health and development. This capability could inform future space exploration and habitation, ensuring that we are well prepared for life beyond Earth. Have you thought about the potential for a Dyson sphere to address issues of resource scarcity? By harnessing the abundant energy of a star, these structures could support advanced recycling and manufacturing processes, reducing waste and environmental impact. This sustainable approach could provide a blueprint for managing resources on a cosmic scale, promoting a future where scarcity is a challenge of the past. Let me leave you with a final thought. The construction of a Dyson sphere represents a monumental achievement in engineering and imagination. As humanity reaches for the stars, it asks us to reimagine what is possible and to strive for a future that transcends the limitations of our current world. These megastructures are not merely dreams of science fiction, but tangible goals that inspire us to innovate, collaborate, and explore the vast potential of the universe. As you ponder these possibilities, let the wonder of the cosmos fill your thoughts. Each fact we uncover is a testament to the limitless potential of human creativity and ambition. Embrace the journey and let your imagination soar among the stars, where the future of our species awaits. Now, imagine the experience of living on the inner surface of a Dyson sphere. Instead of a sky dominated by the familiar sight of space, you'd be greeted by a continuous expanse of land and structures stretching as far as the eye can see. Can you picture a horizon that wraps around in all directions as if the world itself is enveloping you? This unique perspective would fundamentally change our understanding of geography and landscape. Speaking of perspectives, did you ever consider that the temperature within a Dyson sphere could be meticulously controlled? Unlike the fluctuating climates of Earth, the environment inside such a structure could be maintained at an ideal level, free from seasonal extremes. This control over temperature would not only enhance comfort, but could also significantly boost agricultural productivity, ensuring a stable food supply. Here's a curious thought. While we often imagine Dyson spheres as futuristic constructions, some scientists have speculated about the possibility of naturally occurring megastructures. Could there be ancient abandoned structures left by civilizations long gone, adrift in the cosmos waiting to be discovered? This tantalizing idea prompts us to consider the history of the universe and the potential for discovering remnants of otherworldly ingenuity. Have you ever wondered about the role of a Dyson sphere in planetary defense? In addition to harnessing energy, it could act as a shield against cosmic threats, such as asteroids and solar flares. By strategically absorbing or deflecting these dangers, a Dyson sphere could protect the planets within its solar system, serving as a guardian against the tumultuous forces of space. And here's something particularly fascinating. A Dyson sphere's design could incorporate vast networks of gardens and green spaces, creating lush, verdant areas for relaxation and recreation. These green spaces would not only provide a respite from the technological landscape, but could also serve as vital ecosystems, supporting diverse plant and animal life. This integration of nature and technology might foster a deepened appreciation for the interconnectedness of life. On a similar note, consider the potential for communication within a Dyson sphere to transcend traditional language barriers. With advanced technology, it might be possible to develop universal translation systems that enable instantaneous understanding among inhabitants of different cultures and species. This would promote harmony and cooperation, encouraging a society where diverse perspectives contribute to a shared vision of progress. Did you know that the vast interior surface of a Dyson sphere might support entire oceans? Imagine great seas and lakes spread out beneath an artificial sky, complete with weather systems that could simulate rain, snow, and even gentle breezes. These bodies of water would not only be a source of life and beauty, but could also play a crucial role in regulating the microclimate within the structure, maintaining a balance essential for long-term habitation. Here's another surprising possibility. The construction of a Dyson sphere could lead to breakthroughs in nanotechnology. The need to manipulate materials at incredibly small scales to build such a massive structure would drive innovation in this field. These advancements could then be applied to a broad range of applications, from medicine to computing, revolutionizing technology in ways we cannot yet fully imagine. Have you considered the cultural implications of living within a Dyson sphere? With a shared environment and resources, societies might develop new forms of governance and social organization, Traditional concepts of nation-states and borders could dissolve, replaced by communities united by common goals and shared prosperity. This evolution of society could lead to a new understanding of identity and belonging, one that transcends geographical boundaries. Let me share something intriguing. A Dyson sphere could serve as a platform for interstellar travel. With its immense energy reserves, it might be capable of launching spacecraft to distant stars, opening the door to exploration of the galaxy. This capability would transform the structure into a gateway to the cosmos, inspiring generations to venture beyond the confines of their home system in search of new horizons. And speaking of exploration, have you imagined the artistic possibilities within a Dyson sphere? Freed from the constraints of gravity and limited resources, artists could explore new mediums and scales, transforming the interior of the sphere into a vast gallery of creativity. Public art installations could become part of daily life, enriching the environment and sparking inspiration among its inhabitants. Here's an unexpected thought. The construction of a Dyson sphere might also lead to advances in artificial intelligence. As these complex systems require sophisticated management and control, AI could evolve to play an integral role in their operation. This development could enhance the efficiency and safety of these structures, while also raising ethical questions about the role of AI in society. Finally, envision the educational opportunities within a Dyson sphere. With access to vast resources and technology, learning could become a lifelong pursuit, available to all. Institutions of education and research might flourish, dedicated to unraveling the mysteries of the universe and advancing human knowledge. This commitment to education would empower individuals to contribute to the collective advancement of their society, ensuring a legacy of innovation and discovery for future generations. As we reflect on these possibilities, the concept of Dyson spheres and megastructures continues to captivate our imaginations, challenging us to envision a future where humanity harnesses the power of the stars themselves. Embrace the wonder of these ideas and let them guide you into a restful state where the dreams of tomorrow await. Imagine for a moment the architectural marvels that might emerge from the construction of a Dyson sphere. With an unlimited supply of solar energy, architects could defy gravity and traditional design principles, crafting cities that hover in mid-air, or structures that stretch into the horizon without the constraints of Earth's gravity. These new forms of urban planning might inspire a radical rethinking of how we live and interact with our environments, emphasizing sustainability and innovation. This brings to mind the potential for such structures to support extensive transportation networks. Imagine high-speed transit systems that glide silently through the air, connecting different parts of the sphere with ease. These networks could enable seamless movement for people and goods, making the idea of congestion or delays a relic of the past. A Dyson sphere's vastness could also support diverse ecosystems, each tailored to different climates and biomes. Picture lush rainforests, expansive deserts, and serene tundras, all coexisting within the sphere's embrace. This biodiversity could provide invaluable opportunities for scientific study and ecological preservation, fostering a deeper understanding of our planet's own ecosystems. Now, consider the social dynamics at play within such a colossal habitat. Living in a Dyson sphere might encourage a sense of global citizenship, as individuals come together in a shared space that transcends national borders. This could foster a culture of collaboration and mutual respect, where diverse backgrounds and experiences enrich the community as a whole. Speaking of community, imagine the potential for cultural exchange and celebration within a Dyson sphere. With inhabitants from countless cultures, the sphere could become a vibrant tapestry of festivals, art, and traditions, each adding to the collective identity of its society. This cultural melting pot could lead to new forms of expression, blending elements from different heritages into something entirely new and beautiful. As we ponder these cultural implications, it's intriguing to think about the potential for language evolution. In a Dyson sphere where communication barriers are minimized, languages might evolve rapidly, borrowing and blending to create new dialects and forms of expression. Such linguistic diversity could further enrich the lives of its inhabitants, promoting understanding and connection. Imagine, too, the technological advancements that could arise from the need to maintain such an enormous structure. The management of resources, energy, and infrastructure on this scale might drive the development of cutting-edge technologies, from advanced robotics to innovative power systems. These advancements would not only ensure the efficient functioning of the sphere, but could also be adapted for use beyond its confines, benefiting society as a whole. Speaking of technological progress, have you ever thought about the potential for a Dyson sphere to catalyze advancements in space exploration? With ample resources and energy, the sphere could become a hub for the development of advanced propulsion systems and spacecraft, enabling humanity to explore the farthest reaches of our galaxy. This pursuit of knowledge and exploration could ignite a new age of discovery, inspiring people to look beyond their immediate surroundings toward the vast wonders of the universe. Imagine as well the ways in which a Dyson sphere could transform our approach to sustainability. With its ability to harness and utilize solar energy on an unprecedented scale, the sphere might serve as a model for sustainable living, eliminating reliance on finite resources and minimizing environmental impact. This commitment to sustainability could resonate beyond the sphere, influencing practices on Earth and other future habitats. As we explore these possibilities, it's fascinating to consider the role of recreation and leisure within a Dyson sphere. Freed from the limitations of Earth's gravity and weather, inhabitants might enjoy a wide range of leisure activities, from zero-gravity sports to virtual reality experiences that transport them to other worlds. These opportunities for recreation and relaxation could enhance the quality of life, promoting well-being and creativity. In contemplating the societal implications, one might wonder about the potential for governance within such a structure. Traditional political systems might evolve to accommodate the unique needs of a Dyson sphere's population, leading to innovative forms of leadership and decision-making. These new governance models could emphasize inclusivity and transparency, ensuring that all voices are heard and considered in the crafting of policies and initiatives. This brings us to another intriguing possibility: the impact of a Dyson sphere on scientific research. With access to abundant resources and a stable environment, research institutions within the sphere could thrive, pushing the boundaries of knowledge in fields ranging from astrophysics to biology. This commitment to scientific inquiry could lead to groundbreaking discoveries that enhance our understanding of the universe and our place within it. As we journey through these ideas, the potential for a Dyson sphere to revolutionize education becomes apparent. Imagine a society where learning is an integral part of daily life, supported by cutting-edge technology and resources. This focus on education could empower individuals to pursue their passions and contribute meaningfully to their community, fostering a culture of lifelong curiosity and growth. Finally, let us consider the emotional and psychological impact of living in such an awe-inspiring structure. The beauty and grandeur of a Dyson sphere could evoke a profound sense of wonder and connection to the cosmos, encouraging inhabitants to reflect on their place in the universe and their relationship with one another. All of these facets illuminate the boundless potential of Dyson spheres and megastructures, inviting us to dream of a future where humanity transcends its current limitations and embraces the possibilities of the cosmos. As these thoughts gently weave into your consciousness, allow them to guide you into a peaceful slumber, where the universe's vastness and mystery cradle you in dreams of exploration and discovery. One might wonder about the sheer size of a Dyson sphere. Did you know that a full Dyson sphere could potentially encompass Earth's entire orbit around the Sun? This mind-boggling scale means it would have a radius of roughly 115 million kilometers. It's almost unfathomable to imagine constructing something so vast. The amount of material required to build such a structure would be astronomical, quite literally. To give you a sense of perspective, if Earth were dismantled to provide materials, it wouldn't even be enough to create a shell. This leads to the intriguing realization that resource acquisition for a Dyson sphere would likely involve mining entire planets or even asteroids. Continuing to marvel at its grandeur, let's consider the surface area within a hypothetical Dyson sphere. The inner surface could provide more living space than all the planets in our solar system combined. This means that the sphere could host billions, even trillions of inhabitants in a variety of environments. Can you imagine the potential for diverse settlements and ecosystems within this colossal space? Thinking about the energy implications, it's fascinating to note that a Dyson sphere would capture nearly all of the Sun's energy output. That's roughly 400 trillion watts of power. Such an immense amount of energy could power civilization on an unimaginable scale, supporting technological advancements and providing virtually limitless resources for exploration and development. Speaking of exploration, did you know that the concept of Dyson spheres originated from a desire to understand advanced extraterrestrial civilizations? The idea was first popularized by physicist and mathematician Freeman Dyson in the 1960s. He proposed that a highly advanced civilization might build such structures to harness the full energy output of their star. This notion has intrigued scientists and science fiction enthusiasts alike, sparking imaginations about the possibilities of life beyond Earth. On the topic of extraterrestrial life, have you ever considered the potential for Dyson spheres to act as beacons in the search for alien intelligence? The heat and radiation emitted by such structures could be detectable by our telescopes. This thought-provoking idea fuels the ongoing search for extraterrestrial life, encouraging us to look to the stars with curiosity and hope. Speaking of stars, it's interesting to note that not all stars are suitable candidates for Dyson spheres. Stars that are too large or unstable would pose significant challenges due to their intense radiation and gravitational forces. Smaller, more stable stars like our Sun would be more optimal choices. This understanding guides our theoretical designs of Dyson spheres, as we consider the factors necessary for their construction and maintenance. As we ponder the challenges of building a Dyson sphere, it's essential to contemplate the materials required. Some theories suggest using carbon or silicon-based materials due to their abundance and strength. Advanced manufacturing techniques, such as self-replicating machines, could be employed to construct the sphere, saving time and resources. These self-replicating systems might start small and gradually build the structure over thousands of years, showcasing human ingenuity and perseverance. Turning our attention to another megastructure, let's explore the concept of a Dyson swarm. Unlike a solid shell, a Dyson swarm consists of a vast number of individual satellites orbiting the star. These satellites would capture solar energy and transmit it back to a central location. This design is more feasible than a full Dyson sphere and offers flexibility in construction and maintenance. The concept of a Dyson swarm exemplifies the varied approaches humanity might take to harness stellar energy. Another intriguing possibility is the use of a Dyson bubble, a variation of the swarm concept. This involves a large number of lightweight reflective sails that remain in a stable position around the star. These sails would redirect sunlight to specific areas, allowing for precise energy collection. The Dyson bubble demonstrates the creative potential of human engineering, offering another way to achieve stellar energy capture. Did you know that megastructures like Dyson spheres are often depicted in science fiction as utopian societies? They are imagined as places of abundance and harmony where technology solves problems and improves quality of life. This utopian vision inspires us to dream of a future where humanity thrives among the stars, transcending the limitations of our current world. It's fascinating to consider the potential for a Dyson sphere to serve as an observatory for the universe. With its enormous surface area and access to abundant energy, it could house powerful telescopes and sensors, providing unparalleled views of the cosmos. This could unlock the secrets of the universe, revealing new insights into its origins and evolution. Imagine, too, the role that a Dyson sphere might play in preserving biodiversity. Such a structure could serve as a sanctuary for endangered species and ecosystems, protecting them from the challenges faced on Earth. This aspect of a Dyson sphere highlights its potential as a guardian of life, ensuring the survival of diverse forms of existence. Finally, it's intriguing to speculate about the cultural and artistic expressions that might emerge within a Dyson sphere. With its unique environment and diverse population, the sphere could inspire new forms of art, music, and literature. These creative endeavors would enrich the lives of its inhabitants, fostering a sense of wonder and connection to the cosmos. As you drift deeper into thought, let these possibilities gently cradle your imagination, opening your mind to the endless potential of Dyson spheres and the mysteries that lie beyond. Let me share something intriguing about Dyson spheres that you might not have considered. The idea of a Dyson shell is a concept that challenges the laws of physics as we currently understand them. The immense gravitational forces would require the shell to be either impossibly strong or constantly maintained to prevent collapse. This brings us to another surprising fact. Because of these challenges, a rigid Dyson shell isn't likely to be stable, leading more theorists to favor the concept of Dyson swarms or bubbles, which offer more practical solutions. And here's something fascinating. If a civilization were to construct a Dyson sphere, the interior surface could theoretically have artificial environments with varied climates. Imagine walking through a landscape that seamlessly transitions from lush forests to expansive deserts, all within an encapsulated structure orbiting a distant star. This diversity could support a wide range of ecosystems, providing habitats for countless species, much like a microcosm of Earth itself, but on a grander scale. Speaking of grand scale, did you know that the total mass needed to build a Dyson sphere could exceed that of our entire Earth, possibly involving the disassembly of entire planets? This fact paints a picture of a civilization with capabilities far beyond our current technological horizon. It suggests a level of resource management and material science that would redefine how we understand construction and sustainability. Now consider this. Any civilization capable of constructing a Dyson sphere would likely have to possess energy sources far beyond nuclear or fossil fuels. Some theorists propose that such a society might harness quantum or even subatomic forces, tapping into energy levels we can only dream of. This opens up a realm of possibilities for future energy solutions right here on our planet, pushing the boundaries of what's conceivable. Here's a thought-provoking question for you. What if a Dyson sphere weren't constructed for energy alone? Some scientists speculate about their use as massive computing hubs, where they could host incomprehensibly powerful data centers. This could enable simulations of entire universes, unlocking mysteries of existence, and perhaps even allowing for communication with distant worlds through intricate models. Speaking of communication, imagine a Dyson sphere's potential as a cosmic lighthouse, broadcasting signals across the galaxy. Such a beacon could serve as an invitation or a warning to other civilizations, prompting interstellar diplomacy or defense strategies. It's a testament to the profound implications of advanced technology on galactic culture and relationships. Did you realize that Dyson spheres might also serve as a tool for terraforming? By controlling the energy output reaching a planet, they could either warm or cool a world, making it more habitable. This capability could transform desolate planets into vibrant ecosystems, offering a new vision of planetary engineering that extends far beyond our current environmental efforts. Here's another fascinating idea. Imagine the role of a Dyson sphere in preserving knowledge. With its vast energy and technological resources, it could maintain archives of civilizations' collective wisdom, ensuring that knowledge survives even cosmic cataclysms. This concept of a knowledge repository evokes images of a galactic library, safeguarding the intellectual achievements of countless generations. On a more whimsical note, consider how the interiors of a Dyson sphere could be designed to cater to unique cultural expressions. Entire regions could be dedicated to the architectural styles and traditions of different Earth cultures, allowing for a living museum where inhabitants experience a blend of past, present, and future. This highlights the sphere's role not just as a technological marvel, but as a vessel of human heritage and creativity. And here's an unexpected twist. A Dyson sphere might even serve as a giant time capsule. By preserving elements of its creator's society, such a structure could inform future civilizations or visitors about the culture and advancements of those who built it. This time capsule aspect offers a bridge across epochs, connecting disparate eras through shared history. You might find it surprising that the concept of Dyson spheres also influences how we think about sustainability here on Earth. By contemplating the vast resources and energy such structures would require, we gain perspective on our planet's finite resources. This awareness could stimulate innovative approaches to conservation and energy efficiency, drawing inspiration from the grand visions of cosmic engineering. As you let these wonders drift through your thoughts, imagine how each revelation intertwines with the next, painting a tapestry of possibilities that stretch across the stars. The contemplation of Dyson spheres and their implications invites us to rethink our place in the cosmos, encouraging an exploration not just of the skies above, but of the potential within ourselves. In this reflective state, we find not only a glimpse of future marvels, but also a call to nurture the dreams that propel us forward. Imagine, if you will, a civilization so advanced that its creations defy our current understanding of physics. One surprising aspect of Dyson spheres is their potential to manipulate gravitational forces. Theoretically, by adjusting the distribution of mass within the structure, a Dyson sphere could influence gravity wells, which might enable interstellar travel on an unprecedented scale. This manipulation could redefine navigation through space, allowing for shortcuts between distant stars, much like wormholes in science fiction. Here's an intriguing notion. Instead of being solid, a Dyson sphere might be composed of countless individual habitats, each self-sufficient and orbiting a central star. This modular design, often referred to as a Dyson swarm, could offer flexibility and resilience, with each unit operating independently, yet contributing to the whole. It would be like a cosmic community, where each habitat is akin to a floating city, perhaps even hosting distinct cultures or species. Speaking of cultural diversity, consider the potential for a Dyson sphere to serve as an interstellar melting pot. Within its vast expanse, myriad cultures from across the galaxy might converge, sharing knowledge, art, and traditions. This cultural exchange could lead to unprecedented growth in understanding and innovation, much like the Renaissance periods on Earth, but on a cosmic scale. And here's a thought-provoking concept. Dyson spheres could act as massive energy batteries. By storing energy from their host star, they could act as reserves for times when star output wanes, or as a buffer during cosmic events. This capability might safeguard the future of their inhabitants, providing a stable environment regardless of external conditions. Now imagine the potential for such a structure to support life forms beyond our wildest imagination. The controlled environment within could allow for the evolution of unique ecosystems, fostering biodiversity unlike anything seen on Earth. These habitats might host organisms adapted to varied conditions, from high-gravity zones to low-light areas, each thriving in their niche environments. Here's a curious thought. The existence of a Dyson sphere could affect the visible spectrum of its star. If observed from afar, the star might appear dimmer or display unusual light signatures due to the energy being captured by the structure. This phenomenon could serve as an indicator for astronomers seeking evidence of extraterrestrial life or advanced civilizations beyond our own. Speaking of life, consider the sphere's potential role in facilitating long-term human habitation. As an artificial world, it could offer a consistent climate and abundant resources, reducing dependence on external planetary systems. This self-sufficiency could make it an ideal refuge in the face of cosmic threats, such as asteroid impacts or gamma-ray bursts. Imagine the sphere as a hub for scientific experimentation. With its vast resources, researchers could conduct large-scale experiments, testing theories in physics, biology, and technology that are impossible with our current terrestrial limits. These experiments could lead to breakthroughs that redefine our understanding of the universe. Here's something fascinating. A Dyson sphere might even serve as a galactic observatory. Its position and technology could provide clear views of distant galaxies and cosmic phenomena, offering insights into the nature of the universe itself. This vantage point could reveal answers to fundamental questions about the origins and fate of everything we know. The idea of such massive structures also raises questions about their construction. Imagine the engineering feats required, utilizing robotic technology and artificial intelligence to orchestrate the assembly of components in the vacuum of space. This challenge highlights the potential advancements in robotics and AI that might accompany the development of megastructures. Here's a captivating possibility. A Dyson sphere could act as a defense mechanism, shielding its inhabitants from cosmic threats. By absorbing or deflecting harmful radiation, it could protect delicate ecosystems within, ensuring the longevity of life forms that call it home. Speaking of protection, think about the role of a megastructure in climate management. By controlling the intensity and direction of sunlight, it could stabilize temperatures and weather patterns, creating a balanced environment that supports diverse life forms. Another surprising notion is the sphere's ability to serve as a cultural timekeeper. By maintaining a constant environment, it could preserve historical sites and artifacts, allowing future generations to experience the legacies of their ancestors firsthand, much like visiting a preserved ancient city on Earth. Consider, too, the implications for communication within such a structure. With advanced technology, it could host a vast network of instantaneous communication, allowing for seamless interaction between distant habitats. This connectivity could foster a sense of unity and shared purpose among its inhabitants, transcending the vast distances that separate them. As you ponder these possibilities, let your imagination wander across the cosmic canvas of potential. These speculative ideas not only stir the mind, but also inspire a sense of wonder at the universe's mysteries. The concept of Dyson spheres invites us to dream beyond our current limitations, challenging us to envision a future where humanity reaches for the stars and beyond. With each passing revelation, we are reminded of the boundless potential inherent in the pursuit of knowledge and the exploration of what lies beyond our earthly confines. Let me share something captivating with you. Within the realm of Dyson spheres and megastructures, the concept of scale can boggle the mind. Imagine a structure so vast that it encompasses an entire solar system. The sheer magnitude of such a construction stretches our current understanding of architecture and engineering. Picture this. A Dyson sphere could potentially harness the full energy output of a star, which is estimated to be around 384 yotawatts for our Sun. That's a number difficult to truly grasp. Yet it illustrates the immense energy potential such a sphere might exploit. Here's another fascinating thought. The construction of a Dyson sphere might not need to start with a full enclosure. Consider the possibility of beginning with a series of rings or belts that gradually expand and connect over time. This incremental approach could simplify the engineering challenges, allowing civilizations to adapt and scale the structure as their technological capabilities grow. Can you imagine the meticulous coordination required to achieve this? Speaking of adaptation, think about the materials involved in building these colossal structures. Traditional materials might not withstand the extreme conditions of space, leading researchers to propose the use of advanced materials such as carbon nanotubes or even hypothetical materials like metallic hydrogen. These substances could provide the necessary strength and resilience for a structure of such magnitude. It's a reminder of how necessity drives innovation, pushing the boundaries of what we consider possible. Did you know that a Dyson sphere could potentially act as a giant magnetosphere? By creating a magnetic field around itself, the structure might protect its inhabitants from cosmic radiation and solar flares, much like Earth's magnetosphere shields us. This protective feature would be vital for maintaining the delicate balance required for sustaining life within the sphere. It's an elegant solution to one of space's most significant hazards. Here's a curious possibility. Within the varied environments of a Dyson sphere, artificial gravity might be manipulated to suit different needs. By rotating sections of the sphere or adjusting its mass distribution, varying levels of gravity could be achieved. This capability could allow for unique habitats tailored to different life forms or experimental scenarios, offering an unprecedented level of control over living conditions. Have you ever considered the potential for a Dyson sphere to serve as a refuge for threatened species? By creating controlled biomes, endangered plants and animals could be preserved and protected from extinction. These artificial environments might offer a lifeline for biodiversity, acting as a testament to our commitment to preserving the natural world, even as we expand beyond it. Let's delve into the sphere's potential as a vast data repository. With its immense power and storage capacity, a Dyson sphere could archive the collective knowledge of civilizations across the galaxy. This cosmic library might store everything from ancient texts to the latest discoveries, making information accessible to future generations. Imagine the possibilities of exploring such a repository, where the wisdom of countless cultures is at your fingertips. Speaking of preservation, consider the sphere's role in maintaining a record of cosmic history. By capturing and storing starlight over time, it might provide insights into the life cycles of stars and the evolution of galaxies. This cosmic chronicle could help astronomers piece together the story of the universe, offering a window into epochs long past. Here's an intriguing perspective. The existence of a Dyson sphere might indicate a civilization's transition to a post-scarcity economy. With abundant energy and resources, the inhabitants could focus on intellectual, cultural, and technological pursuits. This shift could lead to a society where creativity and knowledge are prized above material wealth, opening doors to new forms of social and economic organization. Think about the potential for artistic expression within a Dyson sphere. With such an expansive canvas, artists could create works on a scale previously unimaginable, from vast installations visible across the structure to intricate designs that play with the light and shadow of the captured starlight. This artistic freedom could result in a renaissance of creativity, where art and science intertwine to inspire and uplift the inhabitants. Here's a thought-provoking twist. A Dyson sphere could serve as a stepping stone for interstellar exploration. With its vast energy reserves and technological capabilities, it might act as a launch point for expeditions beyond its star system. This role could facilitate the spread of civilizations throughout the galaxy, transforming the sphere into a cradle of interstellar culture and discovery. As you consider these possibilities, let your imagination wander through the cosmic tapestry of what might be. Each fact, each idea, invites you to ponder the boundless potential of human ingenuity and the mysteries that await us among the stars. The journey toward understanding and exploring these megastructures is as much a voyage of the mind as it is of the stars, urging us to dream beyond the horizon of the known universe. In this pursuit, we discover not only the wonders of what could be, but also the boundless creativity and resilience of the human spirit. Imagine for a moment the sheer scale of a Dyson sphere, stretching millions of kilometers across space, enveloping a star. This vast structure could potentially house billions, even trillions of inhabitants. In such a scenario, entire ecosystems could be contained within, each carefully crafted to mimic the diverse climates found on Earth. This could mean living under artificial skies, with computer-controlled weather patterns, allowing for eternal spring or everlasting autumn. The idea of a customizable climate is certainly appealing, isn't it? Let's shift our focus to the technological marvels that might be found inside such a megastructure. One intriguing thought is the development of advanced transportation systems, perhaps utilizing magnetic levitation or even teleportation devices powered by the sphere's immense energy reserves. This could enable seamless and rapid travel across its vast distances, making commuting across what is essentially a world unto itself a trivial affair. Can you imagine the convenience and efficiency of such a system? Speaking of energy, the potential for scientific research within a Dyson sphere is staggering. The abundance of available power could allow for experiments that are currently beyond our reach, such as particle acceleration on an unprecedented scale. This might lead to breakthroughs in understanding the fundamental forces of nature, perhaps even unlocking the secrets of dark matter or energy. What discoveries might await us with such capabilities? Another fascinating aspect to consider is the communication infrastructure of a Dyson sphere. With its colossal scale, traditional methods of communication would be insufficient. Instead, a highly sophisticated network would be required, possibly utilizing quantum entanglement to facilitate instant communication across the structure. This would not only enhance connectivity, but could also revolutionize our understanding of quantum mechanics. The thought of instantaneous communication, transcending the limitations of distance, is truly astounding. Now, let's ponder the societal implications of life within a Dyson sphere. The abundance of resources might lead to the elimination of traditional economic models based on scarcity. This could pave the way for a society where individuals are free to pursue their passions without the constraints of financial necessity. Imagine a world where the arts, sciences, and humanities flourish, supported by the infinite energy of the stars. What a vibrant and dynamic civilization that would be. In terms of governance, the management of such a large and complex society would require innovative political systems, perhaps direct democracy enabled by advanced technology, allowing every citizen to have a voice in decision-making processes, is one possibility. Alternatively, a system of highly sophisticated algorithms could assist in managing resources and coordinating societal functions. The emergence of new political philosophies and structures could redefine what it means to govern. Consider the environmental impact, or lack thereof, of these structures. With the ability to harness and convert the sun's energy so efficiently, the need for fossil fuels could be eliminated, resulting in a society free from pollution and environmental degradation. This could allow for the restoration of natural habitats and the healing of ecosystems on Earth. The prospect of living in harmony with nature while exploring the cosmos is a balance many dream of achieving. There's also the potential for cultural exchange that such a structure might foster. If multiple civilizations were to occupy different sections of a Dyson sphere, the exchange of ideas, traditions, and technologies could lead to a rich tapestry of cultural diversity. This intermingling might result in a renaissance of global or even interstellar culture, where new forms of art, music, and literature emerge, inspired by the unique perspectives of various inhabitants. On a more philosophical note, the experience of living within a Dyson sphere could alter our perception of reality and existence. The ability to manipulate environments and conditions might lead inhabitants to question the nature of their reality, much like we ponder the mysteries of the universe. This introspection could inspire new schools of thought in philosophy and existentialism, delving deeper into the questions of purpose and meaning. Imagine, too, the architectural feats possible within a Dyson sphere. Buildings could reach unprecedented heights, and the design of habitats could take on forms limited only by imagination and physics. From floating cities to underground labyrinths, the architectural possibilities are as vast as the structure itself. How might such creativity shape the environments in which life unfolds? And here's an intriguing possibility: the potential for a Dyson sphere to become a beacon to other civilizations. Its vast energy signature could be detectable across great distances, serving as a cosmic lighthouse in the darkness of space. This might foster contact with other advanced civilizations, leading to alliances or collaborations that expand our understanding of the universe. The idea of joining a community of starfaring civilizations is both thrilling and humbling. Lastly, consider the spiritual implications of such a structure. The proximity to a star, basking in its light and warmth, could foster a deep connection to the cosmos. This might lead to new spiritual practices or philosophies centered around the appreciation of the universe and our place within it. The contemplation of our origins and destiny, seen through the lens of a Dyson sphere, might guide us toward a more profound understanding of life itself. As these revelations unfold, let them guide your dreams, inspiring visions of a universe brimming with possibilities. In the gentle embrace of sleep, explore these wonders, where the stars whisper secrets of the cosmos to those willing to listen. Let me share a wonder of cosmic engineering. The sheer scale of a Dyson sphere is almost beyond comprehension. Picture a hollow structure encircling a star with a radius of roughly 150 million kilometers. That's the distance from the Earth to the Sun. Imagine the resources and planning required to construct something of such magnitude. The idea of embarking on a project that spans astronomical distances is both daunting and exhilarating. Here's something fascinating to ponder. The material requirements for a Dyson sphere are equally staggering. Theoretical calculations suggest that dismantling entire planets might be necessary to gather sufficient resources. Think about the logistics of mining entire worlds, redistributing their mass and assembling them into a cohesive structure around a star. What ingenious techniques would we need to develop to accomplish such a feat? It's a testament to human ingenuity and ambition. Speaking of materials, did you know that the outer shell of a Dyson sphere would need to be incredibly thin yet resilient? Some models propose using a material just a few atoms thick. This ultra-lightweight structure would help maintain stability while orbiting the star. The development of such advanced materials could revolutionize engineering and construction, even here on Earth. Imagine the possibilities for lightweight, durable structures in our daily lives. Here's another thought-provoking scenario. On the inner surface of a Dyson sphere, artificial gravity would be created through centrifugal force. The sphere would rotate slowly, with the outward force providing gravity-like conditions. Can you envision living in a habitat where the ground curves upwards around you? The concept challenges our perception of space and orientation, offering a unique living environment that defies traditional notions of up and down. And here's something you might find intriguing: the concept of a Dyson swarm. Unlike a solid sphere, a swarm consists of countless individual satellites orbiting the star in a coordinated pattern. This modular approach could be more feasible, allowing for gradual construction and adaptation. Imagine a vast array of solar collectors, each contributing to a collective energy grid. This flexibility might also allow for expansion as more resources become available. Let's consider the stability of such structures. A solid Dyson sphere would face immense gravitational forces, potentially leading to catastrophic collapse if not perfectly balanced. The beauty of a Dyson swarm lies in its inherent stability. The individual components can adjust their orbits in response to gravitational influences. This dynamic adaptability ensures a sustainable and resilient energy harvesting system, reflecting the harmony between technology and nature. Did you know that the concept of Dyson structures extends beyond energy collection? Some theories propose using these megastructures as habitats for entire civilizations. A fully developed Dyson sphere could support trillions of individuals, each with access to abundant resources and space. Imagine a society where physical limitations are virtually non-existent, fostering unprecedented growth and innovation. Here's an imaginative twist: the potential for a Dyson sphere to serve as a shield, protecting its inhabitants from cosmic radiation and meteor impacts. The outer shell or swarm could absorb or deflect harmful particles, creating a safe haven beneath. This protective layer could ensure the long-term survival of life, even in the harsh environment of space. The idea of a cosmic sanctuary safeguarding its denizens from the universe's dangers is both comforting and inspiring. And here's a curious thought. The aesthetics of a Dyson sphere could vary dramatically based on its design and purpose. From a distance, it might appear as a faint ring or halo around the star. Up close, the surface could be adorned with lush landscapes, thriving ecosystems, or futuristic cities. The interplay between natural and artificial elements could create breathtaking vistas, a testament to the harmony between technology and beauty. Speaking of beauty, imagine the night sky from the inner surface of a Dyson sphere. Unlike the stars we see from Earth, those within the sphere would gaze upon a vast expanse of artificial lights and structures. The familiar constellations would be replaced by a dazzling array of orbital patterns, a living tapestry that evolves with the movement of satellites. What stories might these new constellations inspire? Here's a surprising consideration: the thermal management of a Dyson sphere. With so much energy being absorbed from the star, dissipating heat would be crucial to prevent overheating. Advanced cooling systems and radiators would be essential, perhaps even using the star's energy to power them. The balance between energy capture and heat dispersion could lead to innovative solutions that influence future technologies. And finally, let's reflect on the long-term implications of such a grand undertaking. The construction of a Dyson sphere could span millennia, requiring sustained cooperation and commitment across generations. The cultural and social transformations that accompany such a project would be profound, reshaping our understanding of time, progress, and human potential. Imagine the legacy left by those who dare to reach for the stars, leaving an indelible mark on the universe. As you drift into dreams, let these visions of cosmic grandeur and human endeavor fill your thoughts. The possibilities, much like the stars, are infinite. Let me tell you something truly unexpected about Dyson spheres. Some theories suggest they could be used not only for energy collection, but also for communication on an interstellar scale. Imagine a network of these structures, sending and receiving signals across vast distances, enabling civilizations to exchange knowledge and culture. This intergalactic communication system could foster a new era of interconnectedness among advanced societies. Here's something you might find fascinating: the concept of a Dyson bubble. Unlike a rigid sphere or a swarm, a Dyson bubble consists of numerous lightweight, solar sail-like structures that use radiation pressure from the star to stay in place. This ingenious design eliminates the need for complex orbital mechanics, making it an elegant and potentially more feasible solution for harnessing stellar energy. Can you picture a shimmering array of sails, each capturing sunlight and contributing to a harmonious energy network? Speaking of elegance, did you know that a Dyson sphere could theoretically act as a massive heat engine? By creating a temperature gradient between the hot inner surface near the star and the cooler outer regions of space, it might be possible to generate power in a manner similar to terrestrial heat engines. This method could provide an additional energy source, highlighting the multifaceted potential of such megastructures. Here's a thought-provoking idea: Dyson spheres might be detectable by their infrared signatures. As they absorb and convert stellar energy, they would inevitably re-emit some of it as heat. This thermal emission could be visible to astronomers searching the cosmos for signs of advanced civilizations. Imagine discovering evidence of intelligent life, not through radio signals or spacecraft, but by observing the distinctive glow of a Dyson sphere. And here's something delightful: the potential artistic expressions within a Dyson sphere. With control over climate and terrain, inhabitants could craft landscapes and environments limited only by imagination. From floating gardens to cascading waterfalls, the interior of a Dyson sphere might become an ever-changing canvas, showcasing the creativity and diversity of its residents. Consider the notion of time dilation within a megastructure. If a Dyson sphere were large enough, differences in gravitational forces across its expanse could affect the flow of time in subtle ways. While this might not be significant for daily life, it's a curious reminder of the complex interplay between gravity and time, even in our most speculative constructs. Here's an intriguing thought. The sheer scale of a Dyson sphere could allow for the creation of entirely new forms of weather. With such a vast area to influence, scientists might experiment with atmospheric dynamics that result in unique weather patterns, unlike anything seen on Earth. Imagine witnessing phenomena like rainbows stretching across continents or lightning storms that dance to a symphonic rhythm. Another surprising aspect to consider is how a Dyson sphere might influence the evolution of its inhabitants. With unlimited energy and resources, societies could explore genetic and technological advancements at an unprecedented pace. The environment within such a structure could encourage novel adaptations, leading to biological and cultural evolutions we can scarcely imagine. Did you know that the construction of a Dyson sphere could prompt us to rethink our relationship with natural resources? Harvesting entire planets for materials would necessitate sustainable practices and a deep understanding of ecological balance. This endeavor might drive innovations in resource management, setting new standards for environmental stewardship on Earth. Here's an imaginative twist. The interior of a Dyson sphere could be home to artificial suns, simulated stars providing light and warmth in controlled pockets could create diverse ecosystems tailored to specific needs or desires. These miniature suns would allow for a range of climates and habitats, further enhancing the sphere's capacity to support a wide array of life forms. And here's a curious concept. The strategic deployment of mirrors within a Dyson sphere to focus sunlight could create regions of intense illumination or shadow. This ability to manipulate light would offer new opportunities for agriculture, architecture, and recreation, allowing for spaces that shift between day and night with deliberate precision. On a more philosophical note, the construction and habitation of a Dyson sphere would prompt profound questions about identity and purpose. As we expand beyond Earth, concepts of nationality or culture might evolve into a more unified sense of belonging. Living within a grand human-made structure around a star could foster a shared identity, transcending the divisions that once separated us. Here's something worth pondering: the potential for a Dyson sphere to serve as a launch pad for deeper space exploration. With abundant energy and resources, staging missions to distant galaxies could become more achievable. This megastructure might serve as a stepping stone to the farthest reaches of the universe, inspiring new generations to continue humanity's quest for discovery. Lastly, consider the legacy of a Dyson sphere, a testament to human ambition, ingenuity, and unity. Its construction would symbolize a pivotal moment in our species' evolution, marking the transition from planetary inhabitants to cosmic architects. As you let these reflections settle in your mind, imagine the echoes of our endeavors reaching into the cosmos, leaving a lasting impact on the universe itself. May these thoughts guide you gently into slumber, with dreams as boundless as the stars. As you drift deeper into the world of megastructures, let's explore the idea of Dyson rings. Imagine a colossal ring encircling a star, rotating to provide artificial gravity on its inner surface. The concept, popularized by science fiction, offers a tantalizing glimpse into how we might create habitable space environments. This structure, while simpler than a full Dyson sphere, still presents remarkable challenges and opportunities for creativity in engineering and design. Let's consider the intriguing possibility of a matryoshka brain, a hypothetical megastructure designed for computational purposes. This concept layers multiple Dyson spheres around a star, each using the energy to power vast computational networks. Such a construct could serve as the backbone for an advanced civilization's technological needs, enabling unimaginable processing power for simulations, data storage, or artificial intelligence development. Can you imagine a structure where the very fabric of its existence is dedicated to thought and calculation? Another fascinating aspect to ponder is the energy balance within a Dyson sphere. While the energy captured from a star is immense, managing and distributing this energy efficiently would be crucial. Innovations in energy storage and transmission could transform our understanding of physics and engineering, paving the way for future technological revolutions. The quest to harness a star's power might lead to breakthroughs that benefit even our current energy challenges on Earth. Speaking of energy, there's the concept of a stellar engine, a theoretical device attached to a Dyson sphere that could manipulate a star's trajectory. By directing energy emissions in specific ways, such an engine might propel entire star systems through the galaxy. It's a mind-boggling idea, suggesting that a civilization could not only harness a star's energy, but also navigate the cosmos with it. Imagine the possibilities of steering our solar system, exploring new frontiers as a nomadic civilization among the stars. Did you know that Dyson spheres could also play a role in communication? With the ability to control light and other electromagnetic emissions, such structures might facilitate enhanced methods of interstellar communication. This could allow civilizations to send messages across vast distances more efficiently, potentially connecting different star systems in a cosmic network of information exchange. Here's something to think about: the ecological potential of a Dyson sphere. Within its vast confines, entire ecosystems could be cultivated, tailored to support diverse life forms. This ability to create controlled environments could lead to the preservation of endangered species and the exploration of new biodiversity. It's a vision of a living ark nurturing life in ways we've only begun to imagine. And have you considered the artistic potential inherent in such megastructures? The canvas of a Dyson sphere is practically limitless, allowing for artistic expressions on an unprecedented scale. From landscapes painted with light to structures that resonate with sound, the possibilities for creativity are boundless. Art could become an integral part of daily existence, woven into the very framework of the environment. Here's a thought-provoking notion: the societal evolution within a Dyson sphere. With resources and space in abundance, societies might evolve beyond competition and scarcity, focusing on collaboration and innovation. This shift could redefine societal structures, encouraging values of unity and shared purpose. Living in harmony within such a grand construct might inspire new cultural paradigms, enriching the tapestry of human experience. Have you ever imagined the potential for education in a Dyson sphere? With unlimited energy and access to knowledge, educational systems could become immersive and personalized, tailored to individual learning styles and interests. The pursuit of knowledge might extend beyond traditional classrooms, integrating seamlessly into daily life, fostering a culture of lifelong learning and curiosity. And let's not forget the potential role of Dyson spheres in space colonization. As humanity looks to the stars, These structures could serve as way stations or habitats for those venturing beyond our solar system. They might support long-term missions, providing the necessary infrastructure and resources for exploring distant worlds, thus becoming pivotal in humanity's journey into the cosmos. Imagine, too, the legacy of storytelling within a Dyson sphere. As we create new worlds and experiences, the stories we tell could become as grand and diverse as the structures themselves. Oral traditions, written works, and digital narratives might flourish, capturing the essence of life within these vast constructs and preserving them for future generations. There's also the potential for spiritual and philosophical exploration in such environments. As we contemplate our place in the universe, the experience of living within a Dyson sphere might inspire profound reflections on existence and connectedness. It could provide a unique vantage point for understanding our relationship with the cosmos and our role within it. Lastly, let's ponder the potential for a Dyson sphere to influence time itself. With the ability to manipulate environmental conditions on a massive scale, we might explore the nature of time perception, experimenting with cycles that differ from our earthly experiences. This exploration could lead to new understandings of time and its impact on consciousness, memory, and existence. As you let these imaginative possibilities settle, consider how each idea reflects our boundless curiosity and ambition. Perhaps tonight, as you drift into slumber, these dreams of future worlds will weave themselves into the tapestry of your thoughts, guiding you toward visions as vast as a Dyson sphere itself. May your dreams be filled with wonder, as endless as the universe we seek to understand. Let me share something truly astonishing. The sheer scale of a Dyson sphere means it could theoretically encompass a star, capturing nearly all its emitted energy. To put this into perspective, the internal surface area of such a construct could be equivalent to millions of Earths. Can you imagine an expanse so vast that it dwarfs our planet many times over? Speaking of scale, consider this. The materials required to build a Dyson sphere would be astronomically vast themselves. Some have suggested dismantling entire planets or asteroids to gather enough resources. It's a mind-blowing thought, isn't it? The idea of disassembling parts of the solar system to create something even more magnificent stretches the limits of our current understanding. Here's another fascinating fact. Dyson spheres are not limited to a single design. There are different theoretical configurations, like the Dyson swarm, which consists of a cloud of satellites orbiting a star, each capturing a portion of its energy. Unlike a solid shell, this swarm could be built gradually, expanding over time. Imagine a gradual migration into space, each satellite contributing to the collective energy capture and distribution. Did you know that the concept of Dyson spheres has inspired not just science, but also art and literature? These megastructures have become a symbol of ultimate human achievement and ambition, appearing in countless science fiction stories and artworks. They capture our collective imagination, painting a picture of what humanity could achieve if we reach for the stars. Here's something intriguing. The construction of a Dyson sphere could potentially alter the dynamics of its star. By capturing energy, you might affect the star's natural life cycle. Some theories suggest that this interaction could extend the life of the star, or in some cases, trigger new phases of stellar evolution. It's fascinating to consider how our actions could intertwine with the cosmic dance of celestial bodies. Speaking of interactions, think about the potential for Dyson spheres to serve as beacons. Their presence might be detectable from vast distances, potentially signaling our existence to other civilizations. The very act of harnessing a star could become a form of interstellar communication, announcing our technological prowess to the universe. Here's a truly surprising notion. The concept of a Dyson sphere suggests that an advanced civilization might be able to manipulate gravity on an unprecedented scale. The mass and configuration of such a structure could influence gravitational fields, potentially creating localized distortions that might be exploited for travel or communication. The idea of bending gravity itself to our will is both awe-inspiring and humbling. Have you ever considered the possibility of a Dyson sphere as a habitat for artificial life? With its vast spaces and controlled environments, it could provide a perfect setting for the development and evolution of synthetic organisms. These life forms might adapt to their unique surroundings, evolving in symbiosis with the technology that sustains them. Here's an unexpected twist. A Dyson sphere could serve as a time capsule. With its immense energy and resources, it might preserve information about our civilization for millennia. Even as stars age and galaxies evolve, future beings, whether human or otherwise, might one day unearth these records, gaining insights into the lives and thoughts of their distant ancestors. Consider this fascinating fact. The construction and maintenance of a Dyson sphere would demand unprecedented levels of cooperation and coordination. It's a testament to the potential of collective effort, where diverse skills and knowledge come together to achieve a common goal. This cooperative spirit might extend beyond the construction phase, fostering a sense of unity and purpose that transcends individual and national boundaries. Another captivating idea is the potential for Dyson spheres to serve as laboratories for planetary engineering. Within their controlled environments, we could experiment with ecosystems, climate systems, and even geological processes, gaining insights that could be applied to Earth and other worlds. It's a vision of using megastructures as platforms for exploration and innovation, pushing the boundaries of our scientific understanding. Imagine, too, the potential for cultural fusion within these constructs. As societies expand into Dyson spheres, diverse cultural elements might blend, creating new traditions and lifestyles. This cultural evolution could enrich the human experience, fostering creativity and innovation in ways we can only begin to conceive. Did you know that some theories suggest Dyson spheres could be used to harness dark matter? This mysterious substance, which makes up a significant portion of the universe, could potentially be captured and utilized within the structure, offering new energy sources and insights into the fundamental nature of reality. And here's an intriguing thought. Dyson spheres might not be limited to stars. Some proposals suggest constructing similar structures around black holes, capturing the energy emitted by their accretion disks. This approach might enable us to tap into some of the most powerful forces in the universe, offering new avenues for exploration and discovery. Finally, let's ponder the concept of a Dyson sphere as a vehicle for interstellar travel. If engineered to move, such a structure could carry entire civilizations across the galaxy, functioning as a self-sustaining world on a voyage through the cosmos. This vision of a nomadic existence, traveling among the stars, captures the essence of exploration and adventure, inviting us to dream of possibilities as infinite as the universe itself. As you let these possibilities settle into your mind, remember that each concept reflects the boundless curiosity and ambition that drive humanity to explore and understand the cosmos. Perhaps tonight, as you drift into slumber, these dreams of future worlds will weave themselves into the tapestry of your thoughts, guiding you toward visions as vast and inspiring as a Dyson sphere itself. May your dreams be filled with wonder, as endless as the universe we seek to comprehend.